a leg shot rather is projected from ground level with a velocity u at an angle theta to the horizontal, giving the time t for the leg shot to reach its maximum height as t equal to u sine theta over g, where g is the acceleration of free fall due to gravity. Show that the greatest height reached by the body is u squared sine squared theta over 2g. Okay, using the equation s equal to ut, since the thing is going up, that they say leg shot is fires projected from ground level with a velocity of this u at an angle of this to the horizontal, given the time for the leg shot to reach its maximum is where g is acceleration of free fall. Show the greatest height. Show that the greatest height. So this thing is going up, so g will be negative. That is the point I'm trying to make. Place some borders on the maximum height, and it is shot from ground level. When something is moving upward, it's moving against gravity. So acceleration due to gravity is negative half gt squared. And they say t is u sine theta over g, while initial velocity is u. And this initial velocity, that is u, we know that resolve this into horizontal and vertical component. The vertical component is what is projecting this thing to move upwards to the extent of getting to the maximum height. So that vertical component is u sine theta. Look at this. If I represent the projectile like this is my y-axis, this is my x-axis. Then this one is short like this because this is the maximum height. So we put some borders on reaching this maximum height. Let's call this hmax. And this is the initial velocity of projection. This initial velocity of projection, you agree with me that if I drop a line here, that is a right angle triangle. The angle of projection is theta, and the initial velocity of projection is u. So the vertical component of this theta is this line here. Sine theta is opposite over hypotenuse. So if we call this vertical component, if we call it uy, then sine theta is equal to uy over u. Velocity is set. So that uy is u sine theta. So the vertical component of velocity is u sine theta, while horizontal on the other hand is u cos theta. So is this u sine theta that is propelling this object upward. So that is the initial velocity in respect to the vertical motion. So with that, I substitute that into this. I have u sine theta times, they give us this, which is u sine theta over g. U sine theta over g, then minus half times g times t square is u sine theta over g, then square of it, that's how t square then. U times u is u square, then sine theta times sine theta is sine square theta over g, then minus half times g times u square again, then sine square is sine square theta, sine theta square is sine square theta over g square. So that we have u square sine square theta over g minus, I have g square here, which means g times g. So if I have g times g under here, that means one of the g can cancel this g. So let me just cancel down to square. So that I'll have half times u square sine square theta over g. And when fractions multiply themselves, the numerator multiplies, the denominator multiplies. So 1 times u square sine square theta is t u square sine square theta. Then 2 times g is 2g. LCM of g and 2g is 2g. 2g divided by g will cancel, will be left with 2. Then multiply that 2 by u square sine square theta. That will give me 2u square sine square theta minus 2g divided by 2g is 1. 1 times u square sine square theta is u square sine square theta. 2 minus 1 is of course 1. Then this is u square sine square theta over 2g, which is what they asked us to prove. Question says, show that the greatest height reached by the body is u square sine square theta over 2g. So hmax, the greatest height, u square sine square theta over g.